Okay, rational graphs. So we're going to analyze the non-permitted values first. So I'm worried about the bottom being 0. So I'm going to do some work here. I'm going to factor this bottom here. So it's a difference of squares. So x minus 2 plus 2. Okay, so my non-permitted values are 2 and negative 2 for x. Now, we have to think, is it making an asymptote or is it making a whole? So which one, what should we think? Does it cancel? Is there anything that cancels? Nope. So it's a vertical asymptote for both, actually. Okay, now let's talk about our horizontal stuff. Here's my fraction. Do I have a higher degree on the top, a higher degree on the bottom, or the same degree? So the bottom is a higher degree equation. So what happens? When your number on the bottom is getting bigger and bigger and bigger, we are getting closer and closer to 0. Okay, so we have 3 asymptotes going on our graph. Okay, I'm going to start an XY chart here to get some plotting points. What are some good X values to plug in? What would you pick? I'm probably going to pick 3 and 4 on the right. I'm going to pick negative 1, 0, and 1 in the middle. And then I'm going to pick negative 3 and negative 4 on the left. I'm going to kind of think my zones. I have 1, 2, 3 zones, and I want to know the shapes in each zone. Okay, plug them in. So 3 plugged in. This makes 9 minus 4, so the bottom is 5. Okay, plugging in 4 makes 16 subtract 4, 16 subtract 4, that's 12. You might be a decimal person, whatever you're doing, that's fine. Okay, negative 1 plugged in. So that makes positive 1, and then subtract 4 makes a negative 3. So actually maybe, I bet you for you, maybe you want to think of a decimal, that's fine. So this would be negative 1.3-ish. It's on a graph, so I'm not going to know where you're putting a negative 1.3 versus a negative 1.333. 0 plugged in. So if I cover that up, what's 4 divided by negative 4? Negative 1. Now, you know what? I'm going to copy everything else. Do you realize that if I plug a negative value in or the positive value in, it's going to turn out the same? Because a negative 1 squared or a positive 1 squared is going to be the same thing here. So this is negative 1.3, 4/5, 1/3. I'm just replicating its positive, because if I plug a 3 in, or if I plug a negative 3 in, that's going to come out the same. Okay. So 3, 4/5. So 3, 4/5 4 comma 1/3. What's the pattern? So as we're going right, we're going down, down, down. Okay, the asymptotes help you follow the pattern. Okay, -1, comma, -1.3, 0, -1, okay, and the left-hand side mirrors the other side, the right side, so. Okay. If you're going to be done on your test, you're going to lose 1/2 of a point right now. Does anybody know why I would reduce this person by 1/2 a point? In their communication. Why are they losing a communication point? Do I know how many that tick is representing? No. So I need, if I go 1 and 1, then it's done. To show that each tick represents 1, each tick represents 1. Okay, you just need some number on your axis, and it tells me. Okay, number 2. Non-permissible values. So looking at X, what do we know here? I'm looking to see, is X not allowed to be something? What do you think about this? If I want the bottom to be 0, X squared would have to be a -2. Does that work? No. So there's actually no non-permissible values. Everything works. Okay? Because no matter what you square is positive, plus 2 is still positive. That's not going to ever be 0. Okay, horizontal. So, degree situation. Talk about the degrees. They're higher on the bottom, which means asymptote. Okay, so I only have that for asymptotes. Okay, since there was no vertical asymptote, what do we pick for X values? I would just pick -2, -1, 0, 1, and 2. Okay, because we don't really have a guideline of where to kind of pick. So I'm just going to pick those in the center. Okay. Obviously, I just did that because my top is always 6 no matter what. Okay, plug in a -2. So -2 squared is 4, plus 2 is 6, which is 1. And you know what? The positive 2 is going to do the same thing as the -2. Okay, -1 plugged in or positive 1 plugged in, they're going to be the same. So 1 squared is 1. 1 plus 2 is 3, which makes a 2. And 0 plugged in makes the bottom 2, which makes this number 3. Are you okay? Do you need the Heimlich? Or? Okay, so those are the 5 points. But we have to be careful with kind of the shape we're going to make. This isn't just like a upside down V. Think about this has to get lower, 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 lower. So it's kind of going to be like a bell. Do you know what I mean if I say a bell shape? Okay, last one here. So what are the non-permitted values for X?
Oh, yeah.
Yeah, what's up?
The graph value.
Oh, I lost a half point. I lost a half point. Thank you. Yeah, it's going to be the thing you easily forget. I was thinking of that before I drew it, and then that's why I should just do it at the start. Okay. NPV, X equals 1. Does it cancel? Nope. So therefore it's a vertical asymptote. Okay, let's talk about the degrees. Higher or same? The same, the same. So what's the coefficient from the top? 4. And what's the coefficient from the bottom? 1. So therefore, I'm going to have a horizontal asymptote at 4.
Does the fact that it's a negative, does it not matter with the
Where's the negative?
like the negative 1?
It's how many x's.
Okay.
It's the coefficient of your variable.
Okay.
Yeah. So it's like a 4x divided by 1x. Okay, so this is what it will look like. For asymptotes, I'm going to throw some numbers on there right now before I forget. Okay, if you were to pick some x coordinates to plug in, some x values for your t-chart, I'm going to go with 2 and 3. So I'm going to pick 2 on this side of the asymptote, and then 0 and -1. See where I'm picking from? I look at my asymptote, and I picked 2 on the right of it and 2 on the left of it. Okay. So plugging these numbers in. 4 times 2 is 8 over 1 equals 8. This is 12. This is 2, so 12 over 2 makes 6. 0 plugged in makes 0, because 4 times 0. -1 plugged in makes -4 over -2, which is +2. Okay, so there's the 8, there's the 6. The origin, height of 2, There you go. Okay, just a side note here. Make sure that, let's say I had a hole at 5, 1/4. And I had a graph make sure I can see this if you do have to do it on the test. Okay, make sure I can see it. Okay, got it? You might have to graph a hole, that's what it would look like. FYI, you guys already know I'm really bad at English, but I've seen this on a few people's homeworks.
That's what you texted me yesterday, and I'm like,
No, that's what you texted me yesterday.
No.
Yeah.
No. 100% no.
No.
I know what.
Unless if I auto-corrected me.
It totally did. I did not say that.
Let's see, because,
You did. Yeah, but she did first. Oh.
Where did I do
She
it?
did first.
Where? Where's mine? Prove it.
Under the, what is the, what I asked the point of discontinuity. Sure. And then the hole.
Oh, I did. Ha!
So then I copied you and her hole.
Whoops. It must have auto-corrected me. Okay. Then I can't give you back. Okay, give me everything about this graph. All asymptotes and equations of them. Points of discontinuity, aka if there's a hole. And domain and range. Okay, ready? I'm going to factor this bottom part here. So x minus 2, x minus 1. Okay, so what are the non-permitted values there? X is 2, x is 1. Those are the values that are not permitted. But this time we have a cancel. So at 2 there is a hole. Okay, so we have x equals 1. Got that? A vertical asymptote. A hole at 2, comma, because it says what is the coordinate. So I can't just say at 2. I have to say the coordinate. What are you going to do to get that? What do you want to do to get that? Plug it in. Oops, what am I doing here? X minus 1. Do you know that this is what I'm looking at? Because it's simplified, right? If I canceled that, 3 over x minus 1, right? This is way simplified. You can plug it into the original, but you may as well try for a simplified one. So if I plug in 2 here, I get 3 over 2 subtract 1. So 3 over 1, which makes 3. So there's your coordinate of your hole. And let's talk about your horizontal stuff. Degree situation. Do you have a higher degree somewhere? The higher degree is on the bottom because the top was an x, the bottom was an x squared. So now, there you go. Okay, do you notice how I said equation? So you would be wrong if you wrote vertical asymptote at 1. I need to see x equals 1. Here I need to see y equals 0. Okay, ready? Domain. So we're going to start at negative infinity, what's the first x value that I have to skip over? What are the two x values I have to skip? I can't be at 1 and I can't be at 2. So I'm going to get to 1 and then I'm going to skip over it and then I can continue again at 1. What's the next x value I can get to that I have to skip? 2. And then I can go from 2 again. And now I have nothing else in my way. Okay, range. So I'm going to start with negative infinity. So the bottom of the graph. I'm going. Do you know what y values you can't be at? You can't be at a y value of 0. There's actually another y value you're going to have to skip over. 3, because there's the hole there, so you're skipping over that spot. Okay, so I'm going to go from negative infinity to 0. Then I have to skip the 0, and I can restart. But then I get to 3, and I have to jump it. And then I can start again.
So, should there always be 3 answers like that?
Nope. Here, my domain would go from negative infinity to 1, and then 1 to infinity.
Because there's only one.
There's only one x value that I had to skip over. And then same with this y. Here your domain would go negative infinity to negative 2, skip, and then negative 2 to 2, skip, and then 2 to infinity. Yeah, you see it? Okay. Let's talk about radical stuff. Okay, domain. Tell me if you're heading rightward or leftward there. If you're bigger than or equal to, which direction are you going? You're going right. Are you going up or down? Down. So I'm going right and down. So that's the shape of my radical. So that's not normal. So now is it an A or a B reflection?
A.
And where's my starter? It moved which 2 directions? Left 2 and up 3. Can you take those 3 things and put them into a form like this? I don't know if I put it. I can put it on there if we need it, I guess. Please remember, factor out your B's. I caught a few of you on your last test. Factored it out. Factor it out. Okay, so it should look like this.
Why did you say up 3 when you moving down?
This is a direction of down, but my coordinate is over here.
So then is the x value always going to be the opposite? So like if there was a positive 2, it would have been...
Yeah, because of our transformations, remember?
Wait a second. Wouldn't the negative imply that it's going left? So wouldn't it be going...
Okay, you're confusing the direction of this graph versus, like, it's starting at the coordinate. This is what all I'm talking about. It's the coordinate of the start. Then the negative is the direction of the shape. You know what I mean?
Yep.
So it's not about me doing a left movement, like with my graph. It's about my starter point had moved left.
So then if it would have been a positive 2, the starting point would have been a positive 2.
Yeah, my starting point would have just been here, but I'm still heading like that.
Okay, that makes sense.
Okay, we need to make an equation. This is a rational. So that's a fraction. How do you get yourself into a situation where you have a vertical asymptote at 3? What do you need to see in here? On the bottom. Yeah. How do you make yourself have a hole at -1? You would need an x plus 1 and another x plus 1 to cancel, right? And that's it. You'd be done. Nope, that's it. That's good. Okay, I might ask you more things though. Like what if I told you about some horizontal stuff? If I had said this, if you need a horizontal asymptote at y equals 0, did you meet that criteria? Yeah. So if I had said that, you'd be good, right? Because you have a higher degree on the bottom. What if I said that? What would you need to change in this equation so that you would meet this criteria? What's the situation about the degrees? If there's a horizontal asymptote at 3, what do you know about the degrees? You would need the same degree, and you would need something to divide coefficients. So what would I need to change here? I would need a number, 3, or I could throw in a 6 and a 2, or something like that. But what else would I need? Some other x. So you could just go an x, or you could throw in like a x plus 6 bracket or something. Just something else that would FOIL to be x squared. Does that make sense for meeting the criteria? Okay, graph. Okay, tell me where the starter point is. So I'm only looking, is there anything that's going a C or a D? A C or a D? That's a D, so it moved down 4. You know what I'm going to do right away? My X and my Y tick marks. Okay, now this is an A and this is a B. So I'm going to do an over-up chart. 1, 1, 4, 2, 9, 3. Okay, so this B, do you remember it's always like this? X divided by B. So this column all has to get divided by -1. Are you okay if I just go negative, negative, negative in the fronts of those? And when we talk about transformations, we always think AY. So this column is going to get times by 2 because of the A. So I'm going to write 2, I'm going to write 4, and 6. What am I doing?
It's only the starter that matters with the D now, but it doesn't apply when you change the up. You don't use the D.
The D is just into the starting point, and then I'm done with it.
That's it?
Yeah. Okay, so I have my pen on my starting point, and I'm going to do this. I'm going to go left 1, up 2. Does everybody remember you always go back to the starter point? Left 4, up 4. You can always connect all your visual stuff. Did this vertically stretch by 2? Did it reflect over the y-axis? You see all those visual things? Okay, domain. Left to the right. So negative infinity, 2, 0. What kind of bracket would you be on this one? Square. Did you notice how I used rounds on those rationals? And now these ones are square. Range, the lowest height is negative 4, and then it goes upward. Okay, give me the equation. Okay, so this needs to be left 4, down 3. Left 4, down 3. I need to have that in there. Do we see those things happening? Left 4, down 3. Right? The C part and the D part. Okay, let's talk about the pattern that happened. So I can see a point here and here. Can you actually already tell that there's a negative involved in this? Where's that negative? On the A or the B? It should be a negative on the A, right? So we got to be thinking about that as well. Okay. I went, how do you want to do this? Over, up. I went 2 right, down 1. And then I went 4 right, down 2. Did I do this right?
You went over 1 because there's...
Oh, thank you. I was just going to say this doesn't seem right. Over 1. Sorry, my bad, because this is like a half on the ticks, right? So this is only over 1, down 1. There we go. That makes sense. There we go. Right? Did you do the same as me? So from negative 4 to negative 3 was only over 1. Okay, this is what we did. This is normal. So what's the only thing that we would have to change? That's it. That's the only thing that changed in that pattern. Okay? So then I need a negative on that. I didn't do any stretching. I didn't do any compressing. Okay. Given this graph the radical of it. So what do I know about my rules? If I square root a negative, what do I do with it? Can't. What are some invariant numbers that I'm going to work with? If I square root 1 or 0, they stay. So the height of 0, the height of 1, they stay. Now, what do you know? What do you know about this? When you square root a number between 0 and 1. It actually is bigger. So something like that. And then, you know what I'm going to do? I'm going to take a height. How about, can I find a height of 4? So for instance, right there, I'm going to move that coordinate down to 2. And we better be careful here. Should we end our graph or arrow our graph? End. Okay, be careful with arrows. If you need an arrow, don't need an arrow. Okay, so those are the 3 main ideas. Don't square root a negative. Invariant. Do you want to be above it or below it? Okay, next, solve for the X-Intercept. Okay, I'm going to do all my steps to isolate here. So ready? I'm going to subtract 1. So just algebra stuff. Now I'm going to divide by 2. Now I'm going to square. And now I'm going to subtract 3. Okay, I'm going to graph this equation, but first of all, let's talk about our actual equation that I want to graph. You need to make sure everything is on the same side. So that would mean doing that. Okay, so graphing it, you need to get it as an equation to one side.
Where's the negative 2 from? Where? How are you?
I moved this number over to that side.
Why would you be subtracting 3?
Yep, but I already had a plus 1 there. So plus 1 minus 3. I'm putting those numbers together. Do you see it? I moved that
So
over.
I'm trying to make it equal 0?
Yeah.
Oh.
Yep. So to graph it, you have to have it on one side. Okay, where's your start point on this thing? What's the start point? Left 3, down 2.
Wait. I don't get why we wrote
This?
like for the equation part, what we found was the better X-intercept equation.
Yeah.
Wait, why is it now a left 3?
Left 3, down 2.
Yes, there's positive.
What is positive? This 3?
Yeah.
But that's a C, so it's always opposite.
Oh.
The transformation of the C is always opposite. Remember that? Okay, so there's my starting coordinate. And I'm going to move over and up. So 1, 1, 4, 2, 9, 3. Is not how I'm going to move. What am I going to move? What do I have to do? I have an A value of 2. So what do I want to do with that A number? I want to multiply the Y part by 2. Okay, so I went right 1, up 2, and then I went right 4, up 4. And on this one, you know what's nice? You're going to know if you're right or wrong. Because what's my x-intercept? -2.